Hi Math students, today we're going to look at section 7. Hi Math students, we're going to do task 7.5 part 2. Today we'll start this. We'll start on page 42. This is just a basic overview of what we're going to be doing, and then we'll get into the particular shapes as we progress through the rest of this task. Basically, here we've learned all kinds of things that are going to help us with this task. This is the task where it all comes together. Things like lines of symmetry, rotational symmetry. When we studied quadrilaterals, parallelograms, rectangles, rhombuses, squares, and those properties, all of those will help us now, all those properties that we learned. And then also the congruent triangles, knowing about how to prove that two triangles are congruent, the combination of angles and sides that make two triangles congruent without having to know all 6 pairs of corresponding parts. All of that will help us. And then, yes, of course, isosceles triangles that we just learned about, those are very prevalent in these shapes. We're going to be looking at a rectangle, rhombus, and a square. Of course, a rectangle, it's our quadrilateral with 4 right angles. The rhombus is the quadrilateral with 4 congruent sides. And then if you put both of the properties together of a rectangle on a rhombus, you get a square. It has 4 right angles and 4 congruent sides. So those are the 3 shapes we're going to be looking at. What we're going to do is we're going to look at the shape, and then we're going to identify all the congruent triangles that are within that shape. And on each page we have coming up, we'll have this table where we want to identify the congruent triangles, determine what criteria we use to determine those were congruent triangles, and then how you knew that. So for example, you could say triangle RST is congruent to triangle XYZ, and maybe this is proven based on your picture by side, side, side. So we would want to explain how we know that all these pairs of sides are congruent. And if you just use the lettering here, the order of the letters, you could see that segment RS must be congruent to segment XY, segment ST is congruent to segment YZ, and so forth. And so we would have these 3 congruent sides to show that side, side, side is what makes these triangles congruent. Remember, this is a triangle congruent statement. So our objective is to identify all the congruent triangles, and there's going to be many, and determine why they are congruent in the table. So let's start with the rectangle on page 43. I'd like for you to do as much of this on your own as you can. I'm going to get you started. We have a rectangle. It's a quadrilateral with 4 right angles. And here's some steps of what you need to do at the bottom. So let's follow those. The first one says, draw an example of your selected quadrilateral with its diagonals. So we want to draw those right away. Label the vertices of the quadrilateral A, B, C, D, and the point of intersection N. So if you want your paper to match what mine is going to look like when I'm finished, you can. It doesn't have to be exactly the same. What I'm going to do is start with the rectangle. I'm going to start with A up here. And then I'm going to count down. I'm going to go down. I want an even number. I'm going to count down 8 spaces. That's going to be my next vertex. So draw that. You'll need a straight edge today for sure. And then I got to peek for a second. I'm going to come across. Let's see, I've already counted these out, but I can't remember how far it is. 1, 2, 3, 4, 5, 6. 7's going to be my halfway point. 2, 3, 4, 5, 6, 7 more. So total across, I'm going 14. Remember, yours doesn't have to be exactly like this. You just want to make a rectangle. And also, don't make it a square. Actually make it a rectangle where these 2 sides have different length. This is going to be my point B. I'm going to count down an equal length here, 4 and 4. 4 just to the halfway point. So 8 total. Coming down to here. Let's see. And then finish it. D. And then this says it also wants the diagonals, so I'm going to get diagonal A to C and do this as accurately as you can. The more accurate your drawing, the better your proof part of it will go, because everything will look right. So there's my rectangle with its diagonals. Now here's where I want you to try some stuff. Number 2 says, based on your drawing and the definition of the quadrilateral and information about sides and angles that you can gather based on reflections and rotation, list as many pairs of congruent triangles as you can find. Now already I can see a few. Oh, I forgot to label N in the center. Let's label this point here is going to be N. So I can already see this triangle and this triangle visually look like they're the same thing. We can prove that in a minute. These two triangles look exactly the same. I want to list all of those. And what you could do, if you use your patty paper, you can place your patty paper on, my size doesn't match on this page, it will in a minute. And then do some rotations. Right, so you can do some rotations around and see where, the triangle on the left now shows that it matches the triangle on the right. You can think about how your diagonals bisect each other, and start marking up your triangle with what you know to be true, and then list all that out. When you after you get all that marked up and identify all the individual triangles by name, for each pair of triangles that you get, put those in here. You'll have to write kind of small, or maybe use a separate sheet of paper, the criteria that you know that the triangles are congruent, so you'll need to mark up your picture as you go, and then how you know that the sides or angles are congruent, say by rotation or reflection or some other property. So I would challenge you to stop the video now and actually to try that. What I'm going to do is I'm going to show my solution to this, and I'm going to talk through that solution. So here is my work. There's a copy of this online. You can copy from mine, but hopefully you already tried it for yourself. If you need a little help, you can certainly get help here, or try to just read through my notes that I've posted, and that should help you. Anyway, I used some color coding to try to identify all the different triangles here. And I wrote down a bunch of stuff all in the perimeter space. But what ultimately we're after is to identify all the different congruent triangle pairs. I color coded mine because there are so many triangles here. First, let's look at what I've shown as in blue. If you can see blue, I've got this big triangle on the bottom left and the big triangle on the top right. I've drawn tick marks on the left and right hand side of the triangle, the top and bottom of the triangle. Those are other properties of rectangles we know. On the diagonals, if you think about these diagonals, one of the properties is that they bisect each other, and the diagonals are also congruent. So what I've done is I've marked all the half diagonals equal, and it's the same equal segments in both directions. So I have 3 tick marks on each of those. Now you can use your patty paper to actually show this. Take a look at this, the diagonal AC. If you rotate this rectangle, that diagonal AC sits in the same exact place as the diagonal DB, so that kind of proves with rotational symmetry that the diagonals are congruent to each other. And then also you could show that this half lands exactly on top of this half after 180 degree rotational symmetry. So nevertheless, this big triangle is congruent to that triangle. So let's look on the blue. I have triangle ABC. Triangle ABC is congruent to triangle CDA. Remember, the order of your letters is important. If I look at the markings that I have here, actually, if you look at this big triangle here, I have 1 tick mark here, 2 tick marks on this side, and then basically a pair of triple tick marks here. You can think of this all together as, 2 segments with triple tick marks added together equals 2 segments with triple tick marks added together going the other way. So I have side, 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 if you look at that. So in this triangle, I got this side. In this triangle up here, I have this side. So it's side, side, and then side. The other way we know that this diagonal is congruent in both triangles is because it is a part of the lower triangle and the same exact side is a part of the upper triangle. So AC is congruent to itself. That is a reflexive property. So basically, those 2 sets of triangles, I have side, side, side. And I have a list here of all my reasons. Opposite sides of a rectangle are congruent by definition of the rectangle, and AC is congruent to AC by the reflexive property. So that's one set of triangles, this big set that I have outlined in blue. Now you can do a similar thing with the other set of big triangles. I have them outlined in red. You can see that. So those triangles, that would be triangle in red now. ABD is congruent to triangle CDB. I have those in red. Again, I'm going to use side, side, side for the same reasons that I did on the prior triangle. All right, if we go look at some of the smaller sets of triangles that we have, for example, if we want to look at these two, actually first let's look at these two, these that I have outlined in green. We can think about that. If we look at this triangle on the bottom here, and look at the markings, we have a triple side, a triple mark side, and a double mark side. Just with the markings we already have. Look up here, we have a triple, triple, and a double. So already know, I can tell by these markings that these 2 triangles are congruent, this one and this one. If I think about this from a rotation, let's think about this triangle on the bottom. If I rotate around 180 degrees, that triangle will now be on the top. And so that proves that those are congruent to one another, these 2 triangles. So if I write that out, I have triangle ABN is congruent to triangle CDN. All right. The other thing that we have about this that would help is I named that a little bit different. I named it DCN on my paper. Either way would work. It's side, side, side. The reason either way works on this particular one is because these are isosceles triangles. Look at the markings. These 2 sides are congruent to each other, and then the base is a different size. Do you remember the isosceles triangle theorem that said if 2 sides are congruent, then the 2 opposite angles are congruent? So angle D and angle C down here, and I've numbered my angles. If you'll see, like 1, 2, 3, 4, 5, 6, 7, 8. Angles 2 and 4 are congruent to each other, which means also angle 1 and 3 are congruent to each other. So it really doesn't matter what angle you use and what order these 2 letters are in, because they're isosceles triangles. So given those isosceles triangles, we can actually look at these 2 sets of triangles and these 2 sets of triangles. And think about this. You can show that they're congruent with a reflection, or you can show that they're congruent with a rotation. Here's the justification for side, side, side. The other thing I have noted here is that we have a lot of angles that are congruent as well. We've already talked about some of those, but then also don't forget about intersecting lines creating vertical angles that are congruent. So in that case, angle 11 and 12 are congruent, angles 9 and 10 are congruent, and that introduces basically the idea that almost any of these theorems can be used to prove these triangles are congruent. Added a few extra ways here, and hopefully you can follow along, like side, angle, side, and see that that works. All right, good luck with the